Hello, my name is Ryan Little, and I've been researching the relationship between Siberian forest fires and climate change. In 2019, forests of Siberia caught fire due to unusually high temperatures drying out the landscape. The dry leaves and flora provided ample opportunity for fire on a grand scale. Researchers believe that some of these fires began as a result of lightning strikes, uncommon in the region, and unattended campfires in the backcountry. In total, the fires burned an area of roughly 10,000 square miles, equivalent to the area of Massachusetts. These fires wreak havoc on the local ecosystems they burn through, while releasing toxic fumes and greenhouse gases that only accelerate climate change further. In Western media, Siberia is often depicted as a cold and desolate wasteland covered in ice and snow. This is not true. Siberia is vast and contains numerous climates. The northern part of Siberia that lies within the Arctic Circle has very harsh and very long winters, and a short but not despicably cold summer. However, there has been a warming trend in Siberian climates over the past several decades, and the summers are becoming warmer. For the first time in recorded history, the far north town of Verkhoyansk, known for a winter average of negative 56 degrees Fahrenheit, hit a temperature of over 100 degrees Fahrenheit during a summer. As shown in the graph from NASA, carbon dioxide concentrations have held to a relative pattern for the past several hundred millennia, hitting lows around 180 parts per million and highs from 280 to 300 parts per million. Since the onset of the Industrial Revolution, carbon dioxide and other greenhouse gases have been recorded in much higher concentrations than ever seen before on our planet. This pollution is a leading cause of climate change globally, and our current level is near double what the low is in the natural pattern, settling above 400 parts per million. We know there is a correlation between high carbon dioxide atmospheric concentration and increased likelihood for fires in Siberia. A study done in 2008 comparing atmospheric CO2 concentrations to ancient charcoal and pollen concentrations showed that periods of higher CO2 and pollen concentrations had higher rates of fire in the past 14,000 years. With the rapid increase in CO2 concentrations in recent years due to greenhouse gas emissions, there will be a higher chance of more destructive and larger fires in Siberia. This is not just a Russian issue. It is a global issue with global consequences. Siberia is home to massive tracts of peatland that contain colossal stores of organic material, prime for burning and producing methane, a greenhouse gas 100 times worse than CO2. Peatland fires burn longer and are much harder to extinguish than forest fires, and the release of this methane acts as a positive feedback loop in the system, causing further climate change and increasing the likelihood of fires even more. What has been done to confront this issue? Areas of Russia's forests have been deemed control zones, which are parcels of land that the government allows to burn completely through with zero attempt at extinguishing. These account for 45% of Russia's forests, down from 52% the previous year. Regions affected by the fires get roughly $420 million a year from the federal budget, but conservative estimates by professionals say at least $1.2 billion is needed annually for wildfire firefighting efforts. Pleistocene Park was created in northeastern Siberia to recreate the grassland ecosystem that existed in the last glacial period and to study the climate change in the area that's happening today. My policy recommendations include establishing a fire watch network and a network of fire roads where possible to enable quick response and establish fire lines, to increase funding to regions to acceptable levels in order to properly manage forests and fires, and focus on reducing greenhouse gases on a national level while advocating for worldwide reduction in greenhouse gas emissions. Thank you.